Hello, welcome everybody to channel Sube. Today I am going to discuss question number 47 of 2020 Physics MCQ paper. Figure shows an infinite ladder network of 1 ohm resistors. If the equivalent resistance of this network between points A and B is capital R, which of the following is true? The first one, R is smaller than 2 ohm, R equals 2 ohm, R is greater than 2 ohm, R is equal to 3 ohm, R is smaller than 3 ohm and greater than 2 ohm. So when we are given a question like this to be solved, first of all we should focus our mind to the points they have given to find out equivalent resistance. In this case, point A and B. So point A is this one, point B is this one. So we can't speak about resistance without current. So we have to consider now the current, the path of current. So we have to connect a battery like this to the given points. Now we have to check the path along which the current flow. So current flow like this, it must flow through this 1 ohm, and again when it come back to this point B, it must pass through this 1 ohm. So these two resistors are therefore in series, because all the current from this resistor must flow through this resistor as well. So therefore at least 2 ohm, at least there must be 2 ohm resistance, 2 ohm of resistance. Then this other part, this part, shall we see how it behave. If this part is not here, we have to remove it. Think that this part is not here, only this 1 ohm is there. Then the total resistance is 3 ohm, because here 1 ohm, here 1 ohm, we removed this part, then only 1 ohm is remaining there. So here 1 ohm, then all these 3 ohms are in series, then it must be 3 ohm. But since this part is actually here, what happened is, if we think the current here is I, then the current coming from this junction is higher than that value, because from here also, from these branches also conductivity increase, because little current come from these parts, and they all together make much current than the current alone in 1 ohm. So therefore conductivity increase, then resistance decrease, therefore. So we can draw a single resistor replacing that branch, that network. So we can imagine the resistance of this part of the system is this one. It replaces this one. So here 1 ohm, here 1 ohm, here 1 ohm. If this resistor, if the value of this resistor is 1 ohm, what happens? These two are parallel, then totally of this part, the resistance will be 0.5 ohm. So something like that we will receive 0.9, 0.8, 0.7 or something like that. However, below 1 ohm will be the resistance of this part. Below 1 ohm the resistance will be of this part. So the 2 ohm we must get, this 2 ohm we must get. So 2 ohm is totally there, and some value below 1 ohm should be added. So 2.9, 2.8, 2.7 or something like that we will receive. That means the total resistance is below 3 ohm and above 2 ohm, because 2 ohm definitely we have to get, because it doesn't change, it is there. So therefore 2 ohm totally we get in, and some amount of resistance from this branch below 1 ohm will be added. So the final answer is this fifth one. It is the correct one for this question. So thank you very much for following my videos, guys. So see you tomorrow. Goodbye.